Hey guys, so today we're just going to look at a very small chapter called percentage errors and tolerance. So as humans, we'll make errors in our calculations from time to time, and this can be because of estimation or just simply inaccurate calculations. And you're going to see as well when we talk about tolerance intervals, we will use these next year when we are looking at statistics. So first of all, just to start off with the formula, or I suppose the method. So the error is the true value minus the estimate value. And I just want you to note these little lines here. These lines mean absolute value, and this means that the value will always be positive. So if we get a negative value, we just take the positive. So for example, if you were looking at a packet of biscuits, and a packet of biscuits, so biscuits, the weight is 400 grams, and you weigh them, and the biscuits actually, so that's the estimate. Okay, so sometimes you see that on the packet of biscuits, and then if you actually weigh them, so the true value might be only let's say the true value is 380. Okay, then if I'm getting the error, what happens here is I get 380 minus 400, and what I get is this minus 20, and that's 20 grams. Well, we know that grams, weight, height, there's loads of things that cannot be negative. So what we actually say is that's just 20 grams. Okay, so that's the error. So when you come across something like that, you just simply drop the negative sign. So, but there has to be the presence of these lines here, their absolute value. So there's two formulas then that you just need to know off by heart. These are not in your log tables. And the first one is relative error. So if we take our packet of biscuits, the relative error of our packet of biscuits was, so our error was 20, and our accurate value then was, the accurate value then was 380. So if we pop that into a calculator, then 20 divided by 380 will give me 1/19. And then your percentage error, so I'm just going to use the percentage error, is your relative error, so that RE multiplied by 100. So what we get is 1/19 multiplied by 100, and that will give you 5 point, I'm just going to round this, so 5.26, we'll round it to 5.3%. So that's how much of an error we had in that packet of biscuits. Okay, so let's have a look at this question. The mass of a bag of flour should be 1 kg. A quality control inspector weighs a bag of flour and finds that it is 1010 grams. What is the percentage error? So it's 1010 grams. And first of all, 1 kg, and that's something that you need to know as well. Anything that is kilo is 1,000. So we know then that that's 1,000 grams. Okay, and then we can find then the error. So the error is the true value, which is 1010, minus the estimate. So it should be 1 kg. So that's 1,000 grams, and that's going to give me 10 absolute value, which is fine, that's a positive number, so 10. Okay, then we have the relative error, and that's going to be my error over my true value. So I get 10 divided by 1010, and that gives me 1/101. And my percentage error then is 1/101 multiplied by 100. So I get, multiply that by 100, and what I get is 0.90 9%, and I'm actually just going to round that to 1%, just to make it easier. Okay, so what I want you to do is I want you to take down this question, pause the video, have a go at finding the percentage error. So your 3 steps. First of all, you're going to find the error, then you're going to find the relative error, and then finally you're going to find the percentage error. And what I want you to do then is when you're done, you can play the video and we will go through the answer. Okay, so error then. So the true depth is 1.56 and it's estimated to be 1.6. And I'm going to get a negative number here in my absolute value. So 1.56 minus 1.6, that's going to give me minus 0.04. And because I take the absolute value, it's 0.04. My relative error then is my error, 0.04 over the true value, which was 1.56. So divide that by 1.56 and I'm going to get, and I'm going to leave this as a fraction just so it make it a little bit easier, 1 over 39. And then finally 1 over 39, which is, I'm going to find my percentage error, so that's my relative error, 1 over 39, multiplied by 100. So multiply that by 100, and they've asked me to put that to 1 decimal place. So I get 2.56, so I'm going to put it as 2.6%.